All right, today we're going to start operations with rational numbers. So we want to add, subtract, multiply, and divide fractions pretty much. I'm going to start you off with multiplying fractions. So looking at the way you probably learned it in math class is to say, if we had something like 3/5 times 2/3, you might reduce that before you multiply it, but some students don't. You can just multiply straight across and say 3 times 2 is 6, 5 times 3 is 15, and then reduce this fraction. So notice they're both numbers 6 and 15 are divisible by 3. So if you divide both by 3, you get 2/5. You can also start off with 3/5 times 2/3, and anytime you see something that will reduce, go ahead and do that. So if this were 3/6, you could reduce it to 1/2. Or if this were 2/6, you could reduce it to 1/3. But anything in the numerator that will cancel out with the denominator, you can do that as well. Since the numerator here and the denominator here both have a 3 in common, you can divide each by 3 and then multiply straight across. And what that allows me to do is say 1 times 2 is 2, and 5 times 1 is 5. And I don't have to reduce when I'm done if I reduce everything properly before I multiply. And that's kind of nice when you get into bigger numbers, because you don't want to have to say, does 36 and 125 have anything in common? If you already reduced ahead of time, then it's taken care of. So let's try out another one here. We got 7/5 times 1/2. So once again, multiplying straight across, we get 7/10. So 7/5 times 1/2 is 7/10. Now, all of this is just the algebraic way of doing it. I want to show you some concrete examples here in a moment with like Cuisenaire rods, but we're just doing it the algebraic way at first, and then we're going to understand why it works. Let's look at division. Whoops, not that, division. So if I wanted to do something like 1/4 divided by 1/2, the way I teach my algebra students to remember is to say keep it, switch it, flip it. So I'm going to keep the 1/4, switch division to multiplication, and then flip the next fraction. So keep it, switch it, flip it. Flipping it's also known as taking the reciprocal of that fraction. It's a fancy way of saying flip it. And then multiply straight across like we know how to from the previous slide. So 4 and 2 have a 2 in common, so I can divide each by 2 and then multiply straight across. Or you can notice that, hey, oops, I didn't divide there, did I? Divide that by 2, not just write out 2 again. And so this would become just 1/1 and end up getting 1/2. So 1/4 divided by 1/2 is 1/2. That seems strange, doesn't it? Like, how can you divide something by a half? Once again, I'm going to show you with Cuisenaire rods how we can see this and make sense of why 1/4 divided by 1/2 is 1/2. Let's look at if we were to have a whole number. So if I were to take 3 and divide it by 1/12, what would that be? Well, once again, I'm going to keep it as a fraction as is. You could write it as a fraction if you want to, like that. 3/1, keep it, switch it, flip it. And 12/1 is just 12, so you get 36. So 3 divided by a 12th is a positive 36 there. We could also say what is something like a fraction divided by a whole number. 1/4 divided by 2. Make the 2 a fraction, and then keep it, switch it, flip it. And so 1/4 divided by 2 is going to equal 1/8. Okay? So that's division. If you know how to multiply, it becomes a lot easier to divide. Now, I start off with multiplication and division because multiplication is pretty intuitive for most students. It's what they want to do, is multiply straight across. Division, a little bit more confusing for them, especially if you're talking about the meaning and why it works the way it does. But addition is something that, and subtraction is something that students mess up a lot. They can never remember exactly what to do there. So I like to start off with a basic example, like 1/2 plus 1/4. And students will want to say that this equals 1/6. And that's incorrect, so don't take that. Hopefully you're listening with the volume on. That's incorrect. And I want it, when they ask why is that incorrect, that's what we did with multiplying. We just would have said that was 1/8 if it was multiplication. I like to have them shade out pizza slices. So if this is a pizza, and let's make another pizza here. And if you were to quickly shade that in, you say, okay, I've got a party going on, and we ordered 2 pizzas, and when I went to box these things up, I had half a pizza left over here, and I had 1/4 of a pizza left over right here. And if I add these up to put them in one box so it fits in the fridge a little bit easier, what do I get? I'm not going to get 1/6 of a pizza, because 1/6 of a pizza, there's the pizza divided into 6, is just a slice like that. So it doesn't make any sense to say 1/2 plus 1/4 equals 1/6. So that's a way I quickly show that something's not right here. But I also want them to use that, like if they forget when they come to a quiz or a test or anything, and they start to say, was it multiplication or addition, I could just go straight across with. Have them, if they're familiar with drawing these out, they can quickly check themselves before they answer something incorrectly. So what is the procedure? The procedure is to make these so that they are, they have the same denominator. So remember, the denominator is the bottom number in that fraction. We want to divide those into equal parts. So if we go back to our pizza slices here and we divide these into equal parts, so not into halves, because this one's going to be divided into fourths. Go ahead and divide this one into fourths. And we still shade the same amount though. So 1/2 shade, it looks like this, and 1/4 shade, it looks like this. And if I put this into this pizza box, we're going to get something. Here's our fourths. We got 2/4 up top plus 1/4 gives me 3/4. So the correct answer is 3/4. That's a visual way to represent it, but to represent it using fractions or analytically, we could say if I'm going to take 1/2 plus 1/4, I have to get a common denominator. And with common denominators, it's the same thing as when we found earlier the LCM in the other video. We want to find the least common multiple. So to find the least common multiple, you could do the tricks that we did earlier, but a lot of times on these smaller fractions, it's fairly obvious for most people that both 2 and 4 will go into 4 evenly. So I'm going to write a 4 down here and a 4 down here. These are going to be my common denominators. Just like on these, I divided them into fourths, right? Or I could say fourths like this. So I divided the circles into fourths. That's the visual representation of, the common denominator. Now, why does this work the way it does? Let's see here. What did I multiply the bottom by? I multiplied it by 2. So I have to do the same thing to the top. Multiply it by 2. So 2 times 1 gives me 2. Notice this red fraction right here is equal to 1. So I'm not changing the value of the fraction, because anything times 1 is that original number. And so what I'm doing is changing the way it looks. So it went from 1/2, 1 out of 2 parts, to 2/4, 2 out of 4 parts here. This one didn't change any because I'm multiplying it by 1/1. And now that we've got common denominators, we can just add the numerators. So 2 plus 1 is 3, so you get 3/4. Let's try another example. So let's look at 3/7 plus 2/8. You can pause the video and try it out if you want to. Now, a common denominator for these two is going to be 56. And I can just tell you that it's not always going to be the product of the two numbers. But a lot of times if you can't figure out, if it's not very obvious to you, like what the common denominator could be or should be, you can just multiply the two denominators and that works. You don't have to technically find the least common multiple. You just have to find a multiple that they'll both go into. But usually the least common multiple will make your life easier because you don't have to reduce later on. So since I multiplied the 7 by 8, I got to multiply the top by 8. So that's going to give me 24. And on the right here, I'm multiplying the bottom by 7, so I got to multiply the 7 on the top as well, and that gives me 14. And notice both green fractions are equal to 1, so I'm not changing the value of the original problem there. And now I can just add straight across, and I get 38 over 56. And this will reduce. I know that 38 can be divided by 2. And 38 divided by 2 is 19. 56 divided by 2 is 28. And that's going to be my final answer there. Now, subtracting fractions is going to work in a similar manner. If I had, we'll go back to our pizza story here, if you have half a pizza left in the fridge and we subtract a fourth of a pizza because somebody ate that, then how much pizza do you have left over? Once again, if students get this confused with multiplication, they're going to say 1 minus 1 is 0 and 2 minus 4 is negative 2, and you end up with 0 or no pizza left. So they're probably going to say, that can't be right, but I can't remember what to do. So once again, if we start to draw out our pizzas, it might make a little more sense if they start to see these drawn out. So you got half a pizza, and we're going to remove a fourth of a pizza. So it's going to be taken out of here. Once again, just like with adding, we have to have a common denominator. So I'm going to divide this pizza up into just as many slices as the one down here so that we can compare or subtract these as well. So a half is still the same amount shaded in, but it's the same thing as 2/4 minus 1/4. And just like with adding, where we added the numerators, once the common denominators are found, you just subtract the numerators and you get 1/4 left over. So our final answer here is 1/4 of the pizza is left over. Let's look at another example. Let's say we had 3/7 minus 1/4. So if we had 3/7 minus 1/4, adding or subtracting fractions, the first job is to find a common denominator. And in this case, it's going to be 28. So I'm going to multiply the left fraction by, not 7, multiply it by 4 over 4. And the one on the right by 7 over 7. So this gives me 12 over 28. This gives me 7 over 28. And subtracting the 2, I get 5 over 28. So that in a nutshell is your operations with fractions. And we're going to use that as we start to look at the number line problems that we left off with on the last video. So let's take a look at those problems now. So these can be some challenging problems. I want you to give them a try. Pause the video before you begin this first one. I'll explain what I'm asking here. I'm saying that from here to here is 2/3 of a whole, and I want to know what is the value of x. So if you've given this a try, go ahead and continue watching if you need some help with this or you want to check your answer. The first thing the way I look at it is I'm dividing 2/3 into a bunch of pieces, and I want to know how many pieces there are there. So go through and count these. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 pieces. So I'm taking 1/12 of 2/3. So if I times this by 1/12, I get 2 over 36, which reduces to 1 over 18. So each one of these is an 18th. And you can even check it. If I take it out, you know, that's 1/18, 2/18, 3 of them, 4 of them, and so forth. Out here would be 12/18. That's what 2/3 should be. And that reduces to 2/3. Where is x, though? Count how far out x is. He's out 1, 2, 3, 4, 6, 7, 8. So there are 8/18 there. And that reduces to 4/9. So my answer for x here is 4/9. Try out the next one. I'm saying from here to here is 1/5. Then where is x? Once again, I'm dividing a fifth up into some smaller pieces. Let's see, that's 1, 2, 3 pieces I'm dividing into, or each one of these is 1/3 of 1/5. So multiplying these, I get 1/15. So this is 1 out of 15 from here to here. Right here is 2 out of 15. From here to here is 3 out of 15. And notice 3 out of 15 will reduce to 1/5. Let's continue on until we get to x. We've got 4, 5, 6, 7, 8, 9, 10, 11, 12. X is equal to 12/15, and that reduces to 4 out of 5, or 4/5. Try these two out. So we've got 5, 6. We've got it's being divided up into how many pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to say, what is 1/10 of 5, 6? I get 5 over 60, which reduces to a 12th. So x is at 1, 2, 3/12, which reduces to 1/4. So wherever a whole is, x is 1/4 of a whole. And then this location is 5/6 of a whole. Next one. Here's where x is. There's 3/4. Let's count them up. 2, 3, 4, 5, 6, 7. So remember, x is 7 over something. 8, 9, 10, 11, 12. I'm dividing that into 12ths. So I get 3 over 48. And that will reduce to 1 over 16. So each one of these spaces is a 16th. I've got 7 spaces to get to x, so it's 7/16. And that does not reduce, so x just equals 7/16. All right, if that wasn't challenging enough, these are a little bit different. I'm giving you where 1 1/3 is, and I'm telling you to locate 5/6. And this is kind of a good time to review our mixed numbers here, how we get them, and how to go from a mixed number to an improper fraction. So an improper fraction is a fraction with the numerator larger than the denominator. So if I had something like 12 over 5, that's an improper fraction. And a lot of times in my higher level math classes I teach, pre-calculus, calculus, or whatever, we leave them as improper fractions. But in the elementary and middle school level, most students are taught to change that into a whole number with a fraction next to it. So the way you do that is to say, how many times will 5 go into 12? Or you divide them out like this, and say 5 goes into 12 2 times. You subtract and you get 2 left over. 2 is your remainder because 5 won't go into 2. So it's still being divided by 5 here. So 12/5 is the same thing as 2, because 5 will go into 12 2 times with a remainder of 2. So 2 2/5. Now if I gave you this right here and say change it back into an improper fraction, you would take this 5, times it by the 2, and then add this numerator to it. So 5 times 2 is 10, and then 10 plus 2 equals 12. And that gives you your numerator, and just put it back underneath that denominator there, and you get 12/5. So that's going from improper fraction to a mixed number, and a mixed number back to an improper fraction. Let's do that with the one we have right here. So I want to make this an improper fraction, so I'm going to say 3 times 1 is 3, and then add 1 to it, I get 4. So 1 1/3 is right here. It's the same thing as 4/3, and you can always divide it out and check to see it. 3 goes into 4 once, you got a 1 as a remainder, so it becomes 1 over 3, 1 1/3. So 4/3, I think it's just easier to look at these like that, because then I can divide it up here. I want to know where 5/6 is, and my goal in all of these, first thing I try to do is figure out what is one space equal to. Sometimes I got to change my strategy up, but I want to know what is that fraction that goes right here. So I'm going to say, how many times am I dividing up 4/3? We've got 1, 2, 3, 4, 5, 6, 7, 8. So I multiply this by an 1/8, and I get that each one is equal to 4 over 24. And 4 over 24 reduces to 1/6. So this is 1/6. This is 2 of them. 3, 4, 5, 6, right there. That's where I'm going to place my x. Okay. These will get harder as we go along, but that's our starting out one right there. Next, I'm going to locate 7/8. So I've got a 4th right here. I want to know where 7/8 is, though. Now, what I'm going to do to this starting fraction is I'm going to make it an 1/8. So notice if I make this, or multiply it by 2 over 2, I get 2 over 8. Let me rewrite that out in case you misheard me. 1/4 is the same thing as 2/8. And that means that this one is 1/8 because it's half of 2/8. So you've got 1/8, 2/8, 3/8, 4, 5, 6, 7. 7/8 is right here. Try out number 9 on your own. So for number 9, we've got a third right here. We want to know where the 7/24 is. So I'm going to convert the 1/3 into 24ths. So that would mean I have to multiply top and bottom by 8. And that means that 1/3 is the same thing as 8 over 24. So let's rewrite that. 8 over 24. I want to know where 7/24 is. So 8/24 is right here. How much is each one of these worth? I've got 1, 2, 3, 4 of them. So I'm going to take 8 over 24 and multiply it by 1/4. And before I multiply, I'm just going to reduce these right here. I know that 4 will go into both. 4 goes into 8 twice. 4 goes into itself once. And so this becomes 2/24. Now the reason why I'm not reducing the 24s, I want to leave it into 24ths here. So this is 2/24. And so I'm counting by 2s now. That's 2. This is 4. This is 6. Over 24. And then 2 more puts me at 8 over 24. I want to know where 7/24 is. It's going to be halfway between 6 and 8/24. So we're just going to add our own line right here and make it 7/24. That's where our x goes. Try another one out. Try number 10. So for number 10, I like to find a common denominator for both of them before I start trying to figure out where 3/8 is. So I notice that 3/8 and 1/6 have a common denominator of 24. So to get this into 24ths, I got to multiply the bottom by 4 and do the same to the top. So 4 over 24 is what I get there. For this one, I need to multiply the top and bottom by 3. So 3/8 is the same thing as 9/24. So here's where 4/24 is. I want to know where 9/24 is. And this is the location of 4/24. It's this one right here. So I'm saying, okay, 1, 2, 3. I'm dividing 4/24 up into thirds. And so multiplying straight across here, I'm going to get 4 over, let's see here, 72. So it might help if I go ahead and multiply this top and bottom by 3 as well. And so I get 27 over 72 is the same thing as 3 over 8. And you could divide that out and check it, see if it's the same as 3 over 8, but it should be. So I do all of this to say that each one of these is the same thing as 4 over 72, and I want to know where 27 over 72 is. So I'm counting by 4 70-seconds here. So I've got 4, 8, 12, 4, 8, 12, 16, 20, 24, 28. So here's where 28 70-seconds is. Here's where 24 70-seconds is. So it's going to be somewhere in between where my 27 is, and it's going to be really close to this one. So I'm going to mark it right here like this, and that's where 3/8 is going to be. Okay, where's 27 over 72. All right, another discussion we didn't talk about in the last video because we ran out of time is why can we never, ever, ever, ever divide by 0? And it all goes back to talking about kind of like the example we gave with why a negative divided by a negative is a positive. Look at what fractions mean in respect to division. So if you had 12 divided by 6, you could write it as a fraction like this, and you would say that it equals 2. And the reasoning why is because 6 times 2 equals 12. Or if you had negative 10 divided by 5, that equals -2. And the reasoning there is 5 times a -2 gives you -10. Or if you had negative 36 divided by negative 9, that's positive 4. And the reason is negative 9 times 4 gives you negative 36. But if you say, what is 5 divided by 0, what do you put right here? 0 times what gives you 5? And so there is no number I could put right there, and so therefore I can't divide by 0 at all. Some students get this confused because they say, what if we had 0 divided by 7? Well, in that case, that equals 0. And the reason why is 7 times 0 does give me 0. And so that works there. Some people say you can't take 5 and divide it into 0 groups. It doesn't make any sense. But you could take 0 and divide it into 7 groups. You know, if you got 7 hungry people and nothing to feed them, everybody gets a little bit of nothing, I guess. But if you have 5 meals, how do you divide that amongst 0 people? You can't. So this is usually a good way for me to show my students, at least my high school students, when I'm teaching them, if they ask me the question, why can't I divide by 0? That's what I show them, and that usually clicks with them and makes sense to them. They'll still forget. Everybody does. And so if it's a calculator course where they're allowed to have a calculator, the calculator will tell you real quickly that 5 divided by 0 is an error, and 0 divided by 7 is equal to 0. So under a time test or something pressure, I tell them to refer to that. But I'd much rather my students understand and be able to explain why you can't do it, because it's just good mathematical knowledge versus just taking something at fact or using a calculator to check them. I've got one more thing I want to show you with fractions as far as multiplying and dividing them and such, and that's with Cuisenaire rods. I'm going to save that for a separate video, so it kind of divides it up some for you. Once again, we're getting close to the 30-minute mark, especially if you've been pausing it. So based on your time, we're going to take a break now, and you can watch the second part at your convenience.